To create the diorama of this piece, I decided to use the structure of a lantern. It took a while to get to that conclusion, but after seeing a set of lanterns at a Dollar Tree, I thought it would be the perfect physical and symbolic piece to bring all the symbols for autism together. The coolest and most challenging part of the lantern was to create a chain of turning gears that would travel from the bottom of the lantern to the top and move the wings of the butterfly. And welcome to part 3 of The Robot, the Butterfly, and the Lantern, where we go over the construction of the lantern. To get started, I sourced wood from an old project that has been sitting in the garage for over a decade. I placed the robot on top of one of the pieces and determined placement needs for the entire structure and the circuitry. For the ground that the robot was going to sit on, I actually wanted it to be a jigsaw puzzle. I didn't have to do the whole thing, but I did it anyway. When the puzzle was completed, I took the section that was needed for the floor of the lantern, removed the pieces where I would need to screw in the floor piece to the base, and Mod Podged everything in place. I trimmed the puzzle to the edge of the wooden piece and saved extra puzzle pieces to be added on later. I also drilled the holes that was designated for the robot to be secured to and did a dry test. Once that was done, I continued on to assemble the rest of the lantern. For the ceiling piece, I cut a hole in the middle of the wood for the gear pieces to go through and placed a bevel on the edges. I did this off camera with a jigsaw and a table saw. I then did another dry test with the base of the butterfly and the robot to make sure everything was going to plan. The next step was to create the housing for the motor that was going to be placed in the base of the lantern. Taking the motor from the stem kit, I used some old paint stir sticks to secure the motor to the base. I made the necessary hole for the shaft to fit through and screwed the motor into the paint stir stick. I also connected a modified Technic gear piece to the shaft of the motor. After all that was done, I took time to test the motor to make sure it was still working. To build the chain of gear components, I first cut a hole in the floor of the lantern and began filing the edges in order to accommodate the very first gear piece. I soon realized that I drilled on the wrong side, so there are now 2 rectangular holes on the floor, with one of them that I plan to cover up with puzzle pieces later. However, before I can install the base of the lantern, I need to put in the 4 columns first, as the base will cover the screws used to secure the columns. I add more pieces to the housing of the motor so it can have a secure connection inside the base of the lantern. I first used wood glue to attach the housing to the base, then followed up with some screws. While the glue dries, I worked on constructing the walls for the base. Off camera, I glued them together and drilled a hole for a power switch and then added in screws to make a more secure connection. When ready, I glued the walls of the base to the lantern, cut up and glued some more pieces inside to act as a stop for the base cover, screwed the lantern to the walls of the base, and finished things off by putting the puzzle pieces back in to cover the screws. At this time, I felt like everything was going to plan, and I did not realize the challenges I was going to face when putting all the gear pieces together. I will say that this was a great learning experience when it comes to using motors, gear pieces, and electricity, but man, this was a long process to learn from. To continue building the chain of gear pieces, I worked to add in a new mechanism to connect a brand new gear piece. Using pieces of the paint stir sticks and Technic beams, I was able to get the necessary space to fit the selected gear piece in. The next part was to continue building the chain of gear pieces on the column nearby. To do this, I defined a necessary space with the selected gear piece, drilled the necessary hole, cut out a brass tube that works with a Techno axle and also fits in the hole I just drilled, glue it into place, and finish off by adding in the selected gear piece. I continued this process and added variations to the gear piece up until I reached the ceiling of the lantern. The process took a very long time, so I switched things up a little bit and started gluing random puzzle pieces to the floor of the lantern to create a more interesting surface that also helps cover up the technique beams and holes. The next challenge was to continue the chain of gear pieces from the column to the base of the butterfly in the ceiling. Using technique beams and gear pieces, I determined the correct spacing and start gluing the beams to the ceiling of the lantern. I then began the drilling process to eventually drill and then screw the beams into the ceiling piece to have a strong mechanical connection. I continued building on from the beams to realize that the wooden gear pieces in the base of the butterfly was creating a lot of friction and made it difficult for other gears to turn. Due to this friction, I decided to replace the wooden gears with technique gears. I create some necessary modifications to the gear pieces by cutting an axle piece to fit and then drilling a hole at a sweet spot between the axle and the gear so that they can hold metal pins to transfer the rotational motion to the rods that would move the wings. I did a little test run and everything seemed to be working fine. Keyword seemed. I screw in the ceiling piece back onto the lantern and continue to connect the chain of gear pieces from the bottom to the top. To vary up the look of pieces, I added in more variety and also made some additional modifications to create a stronger connection between gears. I secured more pieces into place and things were just working. From there, I noted that the diorama felt unbalanced. So I continued to work down the right column, and that's when I started having problems. What I haven't been mentioning is that with every single gear piece I added on, I was creating more friction that made the motor work harder. In the STEM project, the motor was only using 3 volts of energy. To get all the gears moving in the lantern, I was pushing the motor up to 12 volts, which was a really bad idea. The safety mechanism in the motor that would set off when the necessary torque was too high broke, and any small amount of friction would keep it from turning. However, with what I know now, I'm surprised that the motor didn't burn out earlier. The second problem I found was that the gears that were used to move the butterfly wings were not firmly connected to each other, making the pins move to unintended spots. To solve the issue with the broken motor, I decide to order 3 different motors to spread out the workload between them, and while I wait for those to arrive, I focus on creating a new apparatus to hold the gears that make the wings move. Using more pieces from the paint stir sticks, I construct a section necessary to firmly hold the gear pieces that move the wings together so that the pins will not fall out of sync. I carefully measured everything, but I still managed to not drill in the right spot. I compensated for the misdrilled holes by gluing on another piece of a paint stir stick, and it worked out perfectly. I secure all pieces by drilling holes and screwing them all together. Note that I am screwing the heads of the screws deeper into the wood as the top of this piece will need to be flush with the base of the butterfly. To set in the gear pieces appropriately, I cut up more brass tubes and secured them into the apparatus with some CA glue and baking soda. I added in the gear pieces and axles and it worked perfectly. I screw in the apparatus to the base of the butterfly and things seem to be working. For now. In preparation for the 3 new motors coming in, I already separate the gear chains into 3 sections. One for the left column, one for the right, and one for the butterfly in the center. I key the shaft of the motors with the technique gear pieces by inserting the shaft into the gear piece and forcing in a screw. I add in another screw for good measure and things look like they work. I test the motors at key positions in the lantern and they all perform to create rotational movement in the gears. Now it's time to put in some focus on the circuitry. Now that I plan to have 2 of the motors sit on top of the lantern, I needed to plan a route for the electrical wiring to feed down into the base of the lantern. So I drilled additional holes in the ceiling of the lantern to create more pathways for the wiring. I also originally had the idea that all the lights and motors would turn on with one switch, but now hearing how loud the gears could be, I decided to separate them into 3 different switches. One for the lights of the robot, one for the fairy lights, and one for the gears that move the butterfly wings. I drilled and filed the holes into shape and did a dry test with the switches, and everything was good to go. It's now time to secure the motors in place, and once they were in, I did a quick test and all the gear pieces were rotating. However, the one thing I haven't done yet was test all these gear parts with the butterfly, so it was time to create the actual connection piece between the butterfly and its base. For the connection piece between the butterfly and the base, I wanted it to look like a hook. I measured out the distance between the test doggy poop bag tube and started a shorter one where the hook would connect to. I also wanted to create a secure mechanical connection between the tube and the base. The method I chose was to pin things into place after the doggy poop bag tube was inserted into position. I drilled the necessary holes and ran a quick test, and sure enough, it felt very secure. I continued drilling more holes in order to insert an aluminum tube as a hook. I cut down the tube to the appropriate size and began working to create a hook with the aluminum tube. I used a tube bending tool to bend the tube to the desired hook shape and trimmed it down.
Okay.
I insert the hook into the doggy poop bag tube and add a quick drop of CA glue to temporarily hold the hook in place so I can make an appropriate mechanical connection. To begin the mechanical connection between the hook and the doggy poop bag tube, I start up by drilling the necessary hole and then adding in a screw. This was absolutely perfect as I planned to remove the hook from the tube many times, and having a position that it had to be screwed into creates consistency. Now it was time for the mechanical connection between the hook and the butterfly. I loosely measured out where the body of the butterfly would be if the wings were in the correct position with the rods connected to them. I marked the position of where the body was in accordance with the hook and solidified the spots to drill and insert screws. I carefully drilled holes into the hook and the corresponding holes into the butterfly and then screwed them both together. I finally added the butterfly to its base and got a full test run with the robot and the butterfly. It was now time to add more details to the lantern. So I got my file out and started rounding out the columns to make them look more like trees. Just kidding, I took the lantern outside with some wood carving tools and a rotary sander to get this result. To help better hide the electrical cable traveling down from the top of the lantern into the base, I trimmed down an aluminum tube and cut out a channel in the 2 front columns. Note that I'm being very careful here as I'm pushing a carving tool toward my bare hand, and for some reason I didn't have the patience to do things safely. I eventually feed the cable through the tube and glue it into the channel. Another thing I did off camera was add this bottom to the base of the lantern. So yes, I cut up some paint stir sticks, glued them up, and screwed them in. The next piece that I wanted to do was add more details to the base of the butterfly, which is essentially the rooftop of the lantern. I sand it down and then take all this food packaging for sesame biscuit egg rolls to add texture to the rooftop. I add in a bunch of pieces around the rooftop and secure each piece with CA glue and, if need be, baking soda. I actually primed the rooftop to get an idea of what it really looks like, and I absolutely love the texture and shanty town roof-like top. The next thing I try to do is wrap a bunch of wire to imply vines around the columns and have them randomly go to places in the ceiling and the rooftop. I kind of got something going on with the first column, but I finally established a process when working on the second one. But before I get to that, I start adding in more puzzle pieces to the ceiling for more texture and to better hide the Technique beams. I also added some greeblies to some of the gear pieces. Now for the second column. I take a bunch of different gauges of wire from thick to thin. I also include a set of braided wire. I then place them into bunches and wrap a small wire around them to hold things together. I also create a 90-degree angle bend to the cables to represent roots. I then take the bunches of cable and place it around the column, wrapping another small cable around them all to hold them in place. You can have this small cable be a temporary piece or leave it there entirely. I then add a bunch of CA glue and baking soda to create a firm hold of the cable to the lantern floor. Once I knew that the wires were secure, I moved the cables to the desired position, unbraiding pieces at key spots to get the look I want. To create more texture, I would wrap smaller gauge wire around other larger sets of wires. I continue this process for the other columns, adding more wire in spots where I feel it may be needed. And I just have these wires sprawl all over the place. I sprayed the lantern with primer, and the one thing I was afraid of was that the gears would get stuck. Fortunately, with a little hands-on encouragement, everything worked fine. But on the downside, one of the gear pieces that was attached to a motor slid out. The other two motors do not have this issue, as the gear piece attached to them have natural obstructions that do not allow any slippage. To remedy the issue, I added an obstruction to the gear holding apparatus. To add more flavor to the gears, I add in more decorative gear pieces and throw in another layer of primer. I double check everything afterwards to make sure that the gears still turn. The next thing I do is add in fairy lights. To do this, I place 2 sets of these long strands of lights that I snake through the lantern. I wanted to add these in before I add textures to the columns and vines, and before I start putting on more paint beyond the primer. One thing to note is that I use galvanized steel for the vines, which needs a different kind of paint if you want it to stick. Fortunately, we are covering the wires with texture that uses Mod Podge as the main ingredient. To finish off this construction stage of the lantern, I do the prep work to add texture to the columns and vines. I use a random mix of matte Mod Podge, baking soda, and brown paint. In this, I don't have an exact formula, I'm just working towards a consistency that looks right. I began painting on this texture using a cheap set of brushes from Dollar Tree, and I keep the fairy lights on to make sure I don't accidentally paint over the lights. When completed, I decide to add in some Mod Podge for good measure to solidify and hold all the textures in place. After putting on a few layers of paint, I consider the construction of the lantern, which is named the Light of the Spectrum, complete. Stay tuned for part 4 of the series for the robot, the butterfly, and the lantern, where we go over the finishing touches and completion for this project. Don't forget that we are fundraising for autism research, so if you would like to support our fundraising campaign, please check out the link in the description below. If you like this video, don't forget to hit the like button and subscribe to our channel, as everything does help out. Special shout out to our patrons and program donors. Without you, we wouldn't be able to do what we are doing. So thank you once again, and we'll see you all next time. Peace out.